Alright, so we've got the Commissioner's Blaster here, and what we're going to go ahead and do is just test out the functionality of it before we destruct it. So, because all the locks are still put in, I obviously can't use it unless I have a magazine with darts in. So, interestingly enough, I'm going to go ahead and try it with these X-Shot darts from Zuru Toys. Put just a few of them in there. They're a little bit shorter than the Elites, as I had mentioned, but I'm going to see if they will work anyhow inside of this Stryfe. It was a good thing to test, so I did just put in some AA batteries here. And if you're wondering what this thing is, I tag my commission so I know who's whose, and I don't confuse it with anybody's. So we'll put this in and give it a test. Revs up fine. Awesome. Well, that's kind of very good to know, actually. This means that Zuru Toys darts for the X-Shot line works just fine in a Flywheel blaster. So that's pretty cool. Now, what we're going to go ahead and do here is we're going to pop this thing open. So I'm going to get started on that by taking out the batteries, flipping it over, then taking out all the rest of the screws, opening it up, and then we'll take a look at the insides. Okay, we've got the blaster apart, and I'm taking out this last piece here. And let's take a look at the insides of the Stryfe. I think everybody who wants to get into electrical modifications for Nerf applications needs to understand the workings of a Stryfe. So many blasters are based on this model that it would behoove you not to actually learn how this all functions so that you can just pop open anything that we in the community call a Stryfe and just be able to do the exact same thing or pretty darn close. So let's kind of start from the top here. This is your barrel attachment, and this is your flywheel cage, and this is where the magazine goes into. This is an annoying lock that checks to see if you have a dart in the magazine or not before it allows you to pull your trigger. So even if you have a magazine, it'll rev, it'll do all of its things, but it won't let you pull the trigger unless this notices that there is an actual dart in here. Now, there's also the magazine release, which we're going to pretty much leave almost intact. We're actually going to replace it with a extended mag lever that I've gotten ahead and 3D printed. This is a lock right here to check to see if there is a magazine before you can even pull on this trigger. So we got to know if there's a magazine in here. We got to know if there's a magazine with a dart in here before all this stuff starts to function. This is your Rev Up Switch, so that when you push it, it'll go ahead and send power to your motors, and the motors will be able to rev up. You'll notice that this tab goes down. So I'll pull this tab goes down, which is what's going to allow you to pull the trigger. That way it'll function in such a manner that you have to have the rev switch going in order to pull the trigger. Then you actually have the trigger mechanism. The trigger mechanism works on a couple of levers. So you pull this back, it pulls this, and let's see if we can't trick it into thinking there's enough here. There we go. So you pull this back, and you'll see it actuating this bar. This is the pusher bar based on these levers right here. And it pushes the dart all the way into the flywheels, and then it returns back with this return spring. And this is where the battery casing is. Under here is where the battery would be on this side, and so this is where the battery casing is. This is where thermistor is at. An easy modification for this is just to kind of connect these 2 points. So you can get it on camera. These 2 points right here to bypass the thermistor. Then you'll be able to put in higher battery powers in here without necessarily having to rewire everything, but it wouldn't be the most functional as far as all the locks would still be in. You'd be running it on low voltage switches, low voltage wiring. You'd still have inductors on the motors, so yes, it would be much better performance than stock, but we can do better than that. And here is in some blasters there's a dart skirt here to kind of help or hinder, depending on what's going on with the dart being pushed into there. In this case, there's a few bars here that are spring based. And that's pretty much the inner workings. Oh, and I forgot one more thing, the jam door. So this is the jam door lock. It is an electronic lock that if we put our jam door back on, you'll notice that if this is not depressed, if this is not depressed, then the power won't continually be transferred to the motors, and it'll happen, this little tab right here on your jam door, that'll happen when this is pushed and closed. You'll see that that pushes down that button on the switch, and now everything is in working order, so that will send the power to the motors. Interestingly enough, if you have everything revved and then you open this up, the way this is wired actually goes back and shorts the motor, and you get an interesting motor break. Motor braking is, if you've ever heard flywheels rev up then rev down, there's a long rev down period, so it takes a few seconds for it to rev down. Motor braking means that it kind of lets the polarity of the motors work against themselves when you cut the power to them, and they rev down faster. I'm pretty sure that Hasbro wired it in such a way so that when this opened up, it did the motor braking to prevent somebody from sticking their finger in there while it was running, by getting it to cut off shorter. What we're going to do in this modification for the Commissioner is, for one, we're going to completely gut everything, take out every single lock, and rewire this. But we're also going to rewire it in a way that's going to do it with motor braking in mind, so that when you pull this, it'll rev up the motors. When you let go of it, it will be wired in such a way that it will do the exact same thing, and it will rev down faster. So that's what we're going to go ahead and do, and I'm going to go ahead and get started by just taking everything out. Okay, so we've completely gutted everything, and I've gone ahead and removed the original locking piece here for the magazine release, and I've replaced it with this 3D printed mag release lever. It's hard to see on the black, I'm sure. There we go, now you can see it. So that way you can just pull that out much easier, much faster, or this way, much easier, much faster. And it works just fine when we put in our clip here and go ahead and simulate that release, and it goes all the way out. So that's how that works. Easy to install. Pretty recommended to do that on your Stryfes. It's pretty awesome and easy to use. You can get it a little bit longer, shaped differently. This works just fine. Got this design off of Containment Crew. I did not make this. This is from Containment Crew. I picked up their design, and this is what I print for what I do for my Stryfes. If I ever do decide to create my own design for this, I will definitely let you know, but this works really, really well. I haven't had the urge or need to kind of redesign it. I left this in place because I will need it, but I took out the locks, and what's going to be going in here is actually a 15 amp micro switch. So I have the micro switch here, and it is a little snap switch with a roller on it, which we probably won't be needing, but may just fine. We'll find out how much of this we're going to need to cut so that it can just kind of trigger really nicely here. And this is going to be better than these stock switches that were in place there, because this will be able to take 15 amps. So we'll be able to wire it in that way and replace that here. A little bit of shell cutting and obviously some glue work to hold this into place. So that's what's going to be going into this Commissioner's Stryfe. Might as well take that out as well, since I'm taking everything else out. And now we're left with a bare and empty shell. I'm going to be leaving the battery trays in its current state here, with the leads all in place. The Commissioner is going back and forth about whether or not to use IMRs or LiPos. For me personally, I understand and I know that LiPos will work better than IMRs. That's just a given. However, I'm not kind of a fanboy one way or the other, so if the Commissioner wants, what I'm going to go ahead and do is wire it to the existing tray here, so that way the Commissioner can still use IMRs, and if he so chooses to, he can convert that to LiPos pretty easily, and just desolder these, put on an XT60 connector, and reconnect the wires, cut out the trays, and all that kind of good stuff. So easy enough for the Commissioner to do on his own, but I will go ahead and rewire everything for him. Now we can take a look at this motor here. So you can see everything else is still kind of all wired up. I am going to be keeping one of these switches, since we're also going to be putting in a voltmeter. I'm probably going to be using this one here, as it's got all 3 prongs. And we're going to be using a voltmeter for this, and I'm going to be using that most likely for the voltmeter. I'm still not yet 100% decided on where I want to put the voltmeter, and the Commissioner has left that to me to decide how and where I should integrate it. The only thing he told me is that he's right-handed, so I will keep that in mind. So we're also going to be replacing these motors, so I'm going to go ahead and pop these things off. We'll need to desolder these leads and then take off the motors from this entire cage system. Okay, and we have removed the motors from their cages, and we took off these flywheels. They've got pretty good little bit of foam buildup on there. That'll be pretty nice. But we're going to go ahead and put those aside. These motors we won't need. This cage we absolutely still will need. So we'll just put that on top for right now. So what we're going to be going ahead and doing is putting in some Rhino motors, Rhino 130 motors into this, and that means we're going to need to do a little bit of shell cutting in here, so we'll be getting out a Dremel and kind of working on that. And putting everything back together once we're all done and rewired. So the thing that this build is doing is going to be taking over, is going to be done in stages. So this is stage 1, which is the destruction. So this destruction is now complete, which means we've taken everything out, taken everything apart that we do not need. So the next phase here is we're going to go ahead and get some of the wiring a little bit done, and then I'm still waiting on some parts to be coming in, those specifically being the motors and the voltmeter. Once everything's there, I can figure out where I want to put it and then really wire it in that specific way. So that's going to be it for the destruction portion. The next portion here is going to be starting to build things up again. Alright, the next part of this, I've gone ahead and done a little bit of shell cutting just to kind of test fit here, but this is pretty much what it's going to look like. We'll still be able to use this plate to lock it down, and then obviously put some supports underneath this to be able to glue it into place. This isn't perfect just yet. This is just a test fit of the things that I've removed underneath here, little bits and pieces like this that I've removed underneath here, so that this will fit with the arm all the way in. You can see it's still moving because it's not glued down or locked down at all, and be able to click in here. So once I like it where I like it for this, we'll go ahead and lock it down. So it's pretty straightforward and simple. You just cut the right amounts here, and then I go ahead and fit it to what I normally do is I just cut that and then go ahead and fit it to exactly the way I want it to, with a very, very light touch on this trigger. And once it's exactly where I want it to be, I go ahead and put additional supports, then glue it down. So The next thing I'm also going to go ahead and do is I'm going to go ahead and cut this down so that this, whoops, this trigger can go all the way back without necessarily catching on this, as there's no lock here, so this is really serves no purpose. That way this will push the darts out. If you ever get a bad dart or something like that, you can still kind of use the pusher to push it out, or pop it open and push it out yourself. One way or the other, you'll be able to do that. All you need to do is just cut that down. This little segment is to show you that I've gone ahead and cut that down, so this trigger will now move back and forth without necessarily affecting the rev portion of the blaster. Okay, so I've got this all locked down, well, not exactly locked down with glue just yet, but pretty much sized up just the way I want it to be. It's pretty, like I mentioned, it's pretty straightforward and pretty easy. At least I think it's pretty easy. You just kind of shave it down here, and now I'm able to use this original lock. I took the lock that was from here, used it here, cut it down a little bit just so that you can use this post to push up against the switch, so that now it's nice and easy. Trigger click. All that's left to do in this area here is to kind of lock that down with some glue at the bottom, just to make sure that this switch doesn't go anywhere. And that's about it. Then we get to the wiring portion, and then I figure out the channels that I want to use. I'm obviously going to need to do some widening of this area over here, and then it's going to go to all of the leads. Okay, so today we're going to be taking a look at installing these MTB Rhino motors. As you can see here, MTB Rhino. We've got 1 and 2 MTB Rhino motors that I picked up from Containment Crew, and we're going to be fitting these into the cage, and obviously they won't fit to start, so we've got to do a little bit of dremeling. So if you can see there, the inside, there are those little tabs, and that's because the standard motors that come inside of the stock Stryfe are actually a little bit smaller than actual 130 size motors, hence the tabs that Hasbro has put into place there. So once we Dremel out those tabs, the motors should fit in rather nicely. Okay, as you can see here, this is the original, where it still has all of the tabs, and this is the one that's been filed down. Now, I filed it down very carefully so that it still has a nice friction fit. Otherwise, if you file it down completely, and it doesn't have that kind of friction fit, you still get a little bit of rattle in the cage, and I don't like that. There's enough sound in this machine, which is one of the things I really didn't like, and I still don't like about flywheels in general, is just that rattling sound of everything, just how much noise it is. I do like them, I do run them. For the most part, I think I've preferenced springers, to be honest with you. Excuse me. But I like them both. Now that that's all filed down, you'll see that this still kind of goes in a little bit tight, but not too bad. It's a nice friction fit. Just a very perfect flush finish for a friction fit. Now we'll go ahead and do the same on the other side, and this will be ready to go. Okay, we've gone ahead and gotten everything in here. It's a nice friction fit, as I mentioned, just the way I like it. So these motors aren't going to go anywhere anytime soon. I like the friction fit because in these specific cages they don't have any holes here to really lock down your motor. So you're really relying on this, and there's no wiggle or wobble room there. So now we're going to go ahead and take our flywheels and pop them back on. There we go. Am I just missing the hole? There it is. Okay, there's one. And we'll pop in number 2. There we go. So we've got both flywheels nice and in place. Awesome. And this is ready for a cage installation. So there we go. Okay, we've gone ahead and put the motors in, and we've put together the initial leads here to be able to connect the motors to the polarities. The other thing to note is when you are putting the motors in, make sure that that they are on opposite sides. So there's red here and then there's red here. They're not running on the same sides. So you want to make sure that's in place. Next thing to do here is to go ahead and create some leads. Oops, wrong way, this way. I also cut the tab here that used to push down the smaller gauge wiring, which will not work for this larger gauge wiring. So we've gone and done that. So next thing I'm going to do is I'm going to go ahead and create some leads here for these wires to go ahead and go out and through to the rest of the blaster. If you're wondering what kind of wires these are 16 gauge audio wires. So we're going to be able to run quite a bit of power through these. Okay, and we've gone ahead and wired up the motors here together, and we've kind of connected all together out here. I've gone ahead and, like I mentioned, cut this tab so that we can kind of stuff the wires in this way underneath and into the shell. These are a lot thicker wires than what Hasbro originally had put in here, so there is going to be quite a bit of shell work in little bits and pieces all over to make sure to get it to fit in its shell here. So it's just going to be I think I've cut most of it, but just a little bit of finagling to make it fit into the original shell on the Stryfe. And as you can see there, it's getting pretty tight. So I'm going to do a little bit more shell cutting than I think I'm going to be able to close this up. Okay, so we've gone ahead and wired things up. So the motors have been locked down, and we've got the leads coming out of here for the wires. It's been locked down with hot glue because the original one will not fit 16 gauge wiring. Move this out of the way. This is locked down here as well. Some shell cutting in this area as it's going through here. Then it splits right here so that we can do the motor braking. So we've got the negative terminal, which normally just ends there, but now is going to continue all the way back down to the normally closed position on the switch. And normally what you have is the positive from the battery going into the common, and then the normally open going all the way to the motors. But in order to do the motor braking, we have to do a little bit of changing things up on this. So what we actually have is the power from the battery is actually not going into the common, but rather is going into the normally open, and then the common is going to be taking its energy from where the batteries where the motors are, and then the negative is going back to, as I mentioned, the normally closed. What this is going to go ahead and do is it's going to give us a nice rev up, but then it's going to short at the motor by the way it's wired to shut the motors down faster. So if you'll notice, and this is running on stock alkalines by the way, so it's not significant just yet, but if you notice, there's going to be a rev up time and then a very, very short rev down time. So here we go. So I hope you can hear that. So I hope you can hear how short that rev downtime is, which for this kind of a sleeper modification is going to be really nice because you'll be able to run around and then go back to silent mode pretty quickly. I've also got the LEDs wired up here. I'm not entirely exactly sure where I want them, but I think I have an idea, and they're kind of working off of a switch right now. As you can see, they're lighting up when I push this switch. And they're connected obviously directly to the batteries with a little bit of a stop right here through this switch. And they're running on 0, right now because we're just running on really low stock alkaline batteries. So once we get like IMRs or a LiPo in there, that should be running just fine. That being said, I've also kind of greased everything up, and this is pretty much ready to go as is. This is the only other piece that I'm going to change out and figure out where I want it to be. And once that's done, I'll be able to close this up and show you how everything works and functions. Oh, and one more thing. Let's go ahead and test the polarity. Now, what I did, because as you can tell here, these are the same colored wires. What I did is I just kind of wired everything up, and when I got to this point over here, I went ahead and split the wires, tested to figure out which one's positive and negative, and that's how I determined where to put things. That way I knew it was going in the right direction. So I'm going to go ahead and rev this up and I'm going to rev this up and put a dart through. There it goes. Even on stock alkalines, that's hitting pretty hard with the Rhino motors. Now, I'm not going to do this too often because these Rhino motors are going to be drawing a significant amount higher than what is going to be outputted by these stock alkalines. So this is just for testing purposes. Would absolutely not recommend this incredibly off-balance source of power to the draw. So I'm going to go ahead and cut it right here and then figure out where I want to put the LED voltmeter, close it up, and I'll show you when I'm done. Alright, and we are going to be taking a look at some final thoughts on this Super Stryfe mod, and I've even printed some 3D parts for it here that are not going to the commissioner, but I've just kind of been play testing it a little bit. I've had some time, a few days in fact, to kind of play with this, shoot it around the house, shoot it down the hallway, which I'm going to be doing a range test video for it as well. But I just kind of want to go over it real quickly. The commissioner wanted something that would be a sleeper modification, which this pretty much is. There's a couple of notifying points that this is modified. Number one being this extended mag release. It is done up in black, so it's less obvious. And also, the more obvious voltmeter over here, but it's on the inside. So usually you'll be seeing this outside face, and the commissioner is right-handed, just as I am, and had mentioned that he was right-handed. So there's a couple of things on the right hand side. Number one is this voltmeter that's going to be visible here to the shooter, and the second is this push button that will turn on the voltmeter. So we're going to go ahead and push it, and you can see it's running off of 11 volts, and currently this is wired into the original battery tray, so it's taking in AA batteries as the commissioner had requested. This would be 3 LiFePo 4 batteries and 1 dummy battery, so that's about 11 volts that it's running on. It's not full charge, but again, I've been using it for the last few days. So we can see that all of the locks are removed. I can rev it, no problem. I can pull out this clip nice and easy. My darts, there we go. Pull out this clip nice and easy with that extended mag release. I can also keep pulling the trigger, so every lock in every way has been removed on this, electronic and mechanical. Everything's been shaved down, fit nicely. It's running off of a 15 amp microswitch here, as I've already kind of shown before, running on 2 Rhino 130 motors, completely rewired on 16 gauge wiring, as I've shown previously. And that's, I think, all the goodness inside of it. Yeah, so what I'm going to go ahead and do is I'm going to go ahead and pop this magazine back in. It's got 2 Elite darts, 2 long distance Busby darts, and 2 Venka FVJs. I'm going to go ahead and pop that in there. And these are not particularly new darts whatsoever. These are worn in darts, so this should give kind of an accurate comparison. I like shooting with worn in darts to kind of give more of an accurate comparison of what it would be, because you know, you'll probably find more worn in darts than anything out in the field. So I'm going to go ahead and do a little demonstration for you, just right here. You can hear how much louder that hits, and also how much louder that motor is. Another thing that I hope you can hear is that the motor is done up in, that the circuits are wired up in such a way that it does what's called motor braking, which is basically that the motors don't have a long rev down time. As soon as I depress this button, the currents are flowing in such a way that it reverses the polarity, basically, that the motors were going in, and shuts it down much, much faster. There's a guide that I'm going to go ahead and link in the description box below on Nerf Haven on how to do such a modification, and that's what I did here. So you can hear that it'll rev up pretty quickly and then rev down almost instantaneously. So usually you'll have like a few seconds delay before you get to be in the quiet mode, so to speak. So not only is this modification a sleeper modification, but it's sort of like a ninja modification. You'll be sniping somebody from wherever you're at and then turning it off quickly and running away, and they won't exactly know where you've trailed off to. So that's kind of a fun little benefit for those that run flywheel blasters. I think that's a good modification for you to do. That being said, I'm going to go ahead and do a outdoor range test with the same harmonica magazine of darts. I'm going to put the FVJs, then the Busbies, and the Elite darts. So we're going to go ahead and take this outside, and then we'll come back in for some final thoughts. Okay, we're in the hallway. As I mentioned, we've got the 6 mag of darts, the 3 of a kind. We're going to go ahead and fire this shoulder width, sorry, not shoulder width, shoulder height flat down this hallway, and here we go. Okay, let's go take a look at those ranges. So, this is coming up at around 41 and 42, 45, 47. This is at the 60 mark and 65. Okay, we're at range test number 2. We're going to go ahead and fire it flat again. That was a lot of dart roll in those last two. I'm going to probably have to take off like 3, 4, 5 feet. So this is at 40, pretty much exactly. 42, 44, about 55. These would be at around 80, but I'd say 75 because they rolled quite a bit. Here we go, last time. 6 more shots flat. We're going to try to see if we can't keep it down this hallway. About the same ranges, to be honest with you. So I'm just going to call it at that. Okay, and we're back. The range tests were done, and the ranges, on average, were going anywhere between 40 feet to about 80 feet pretty consistently. There's a few outliers, not the ones that are close, because those usually happen because the dart hit a wall, but the ones, the outliers that were firing further out. In all of my testing, I think we're hitting a little over 100 feet at that time, but not very consistently, and it was not with any of these two dart types. It was with the FVJs. So the different kind of foam heads obviously have something to do with that. But if we're going to go with stock ammunition, I would say stock ammunition was hitting an average of about 65 to 70 feet flat. So if this is what you're running, that's probably what you'd expect to get. If you're running any other kind of ammo, depending on that head, you're going to get better or worse performance, as to be expected with flywheel blasters. So this is the end of the video. We've got this going off to the commissioner. I know he already likes it, as he's seen a lot of the build along the way. So I will be parting with this soon, and it will be heading his way, and I hope he gets a lot of good use out of it. That being said, if you enjoyed this video, please leave me a like. If you have any thoughts, comments, or things you'd like to see in future videos, or anything about this build of itself, go ahead and leave me a comment in the comment section below. Give me a like, show me some love in this video. And subscribe if you haven't already. Thank you guys for helping me hit 100 subscribers, and contest information will be coming up soon. Have a good night.